For 7.1 Part 2, we're going to look at multiplying and dividing rationals. First, I want to look at multiplying rationals. When you multiply rational expressions, the first thing you're going to want to do is factor every numerator and denominator you see. So you're going to have two separate rationals. You're going to factor both numerators, factor both denominators. Then you're going to go ahead and multiply across. In other words, you're going to take a whole bunch of quantities and multiply them across. And then last but not least, you're going to cancel or reduce what you're left with. For our first problem, I want to start off with a pretty simple one. We're going to start off with 5p minus 5 divided by p times 3p squared divided by 10p minus 10. So since I'm multiplying both of these rationals, the first thing I want to do is actually factor every piece that I see. So I'm going to start right up here with 5p minus 5. It looks like there's an LCD of a 5, excuse me, a GCF of a 5. So I'm going to pull that GCF out, giving me 5 times p minus 1. Next, I'm going to look at this denominator. This denominator is just p. There's nothing to factor. Carry my multiplication sign. 3p squared, there's nothing to factor. It's just 3p squared. And then I look at this denominator. It looks like there's a GCF of a 10, so I'm going to pull that 10 out. Now, once you get here and you've got everything factored, what you want to do is go ahead and multiply everything across. Now, you got to be careful. We're going to put monomials with monomials, and we're going to keep quantities separate. So 5 is a monomial, 3p squared is a monomial. We're actually just going to multiply those together, and it's going to be 15p squared. This p minus 1 is a quantity, so he's going to stay p minus 1 as a quantity. Over, okay, once again, I'm going to keep my monomials together, 10 and the p, so 10 times p is 10p. And then this p minus 1 is a quantity, so I'm going to keep that p minus 1 a quantity and just carry it over. Now at this point, do not make the mistake of multiplying this stuff in. You're gonna undo everything we did right here. We want this factored out because right here we're going to go ahead and just cancel our common factors. So I'm going to start by looking at 15 over 10. Now I'm going to reduce that just like it's a fraction. It looks like they're both divisible by a 5. So I'm going to divide them both by a 5, and it looks like I've got 3 over 2. Now I'm going to look at my p's. It looks like I've got p squared over p. Well, p squared over p is actually just one extra p in the top. And then last but not least, I've got my quantities, p minus 1, p minus 1. Those are exactly the same, and they are both factors since it is times here. So I'm going to go ahead and cancel both of those, leaving me with my final answer of 3p over 2. Now let's take a minute and look at dividing rationals. So when you divide rationals, you actually follow your multiplication rules. The only difference is you've got to multiply by the reciprocal of that second fraction. So in other words, you've got to take that second rational and actually flip it, and then reduce like normal. Okay, let's say that I give you these two rationals and we're dividing them. So we're going to follow our multiplication rules, but the first thing that we have to do is flip this second fraction, and yes, it does matter. It does have to be the second one. So I'm actually going to physically rewrite this problem in its entirety. The only thing I'm going to do is I'm going to flip that second fraction. The minute you flip that second fraction, that division sign becomes a multiplication symbol. So the minus 3x minus 18 pops up to the top, and the positive 7x plus 12 jumps into the denominator. Now, if you follow our multiplication rules, the first thing that we say is factor each and everything that you see. So let's start with that x minus 6. Well, that x minus 6 can't be factored. It's linear, and there's no GCF. Now, x squared minus 12x minus 36, I'm looking for two things that multiply to a positive 36 and add to a negative 12. So it's going to be negative 6, negative 6. Looking at my second fraction in the numerator, I'm looking for two things that multiply to a negative 18 but add to a negative 3. So it's going to be x minus 6x plus 3. And then two things that multiply to a 12 and add to a 7, positive 4, positive 3. Now we're going to go ahead and actually multiply these across, but remember we've got to keep quantities with quantities and monomials with monomials. So if I'm looking at this numerator and I'm multiplying this whole thing across, they're actually all quantities. This x minus 6 is a quantity. It's together in and of itself, quantity and quantity. So it's going to look something like this when I multiply it across. Same thing with the denominator, except there's more. There's one extra. We've actually got x minus 6, x minus 6, x plus 4, and x plus 3. There's 4 of them. And now we're going to go through and cancel any common factors. And remember, a factor has to be something that's multiplied. So x minus 6 and x minus 6 are both factors. I can cancel them. X minus 6 and x minus 6, once again, both factors. X plus 3, both factors. Leaving me an x plus 4 in the bottom and nothing in the top. The way that we represent nothing when we're talking about rationals is a 1. So your simplified answer would be 1 over x plus 4.